Hello students, today's video is about linear algebra part 6, and in this video we are going to discuss about homogeneous linear equations. So let us watch the video. Hello my dear students, welcome back to your channel, and today you are watching linear algebra system of linear homogeneous equations. This is lecture number 6 from the series of linear algebra. So let us quickly go with the homogeneous linear equations. What are these particular things? So homogeneous linear equation has this particular form: a11x1 plus a12x2 plus a1 and xn equals 0, and like this it will continue. Now if you compare this particular one with that of non-homogeneous linear equations, now where do you find the difference? Yes, you're absolutely right. The difference is here in the RHS. In case of non-homogeneous linear equations, we had b1, b2 till bm as constants in the RHS, but here in case of homogeneous linear equations, we do not have anything in the RHS portion. The RHS portion is absolutely 0. So we can say here that we have a coefficient matrix A, we have a variable matrix X, just like non-homogeneous linear equations, but there's a difference between non-homogeneous and homogeneous. The difference lies in here. We do not have any constant matrix, we have 0 here. So as a result, we also do not have augmented form here, because augmented form is the combination of coefficient matrix and the constant matrix put together. But there is no constant matrix, so no augmented form. So in this case, in order to find the solutions, we have two case studies, two different things we need to consider. The first thing is that the rank of the matrix, of the coefficient matrix A, will be either equal to that of the number of unknowns, or it will be less than the number of unknowns. Now what are the number of unknowns? Number of unknowns means the number of the variables present in the equation. Let's say if the equation is having x, y, z as the variables, so there are 3 number of unknowns. If it has x and y as variables, there are 2 number of unknowns, just like that. So this will be the value of n. And if the rank of the coefficient matrix is equals to that of n, we will have one different case. If it is less than that of n, we will have another different case. Now if you don't know how to find out the rank, how these things are coming, I will request you to watch the video that I've made on rank and echelon form of matrix. So it's there in the description also, and I will be giving this on the I button as well. So you can check out the entire series and you can find out the rank, echelon form, about the non-homogeneous systems and everything. So anyways, coming back to this particular thing, so there are two case studies we need to study. So the first one is that if the rank of the matrix, of the coefficient matrix A, and the number of unknowns are equal, we are getting our trivial solution. Now what do you mean by trivial solution? Trivial solution means whenever we are getting a trivial solution, it means all the variables present in the equation series will give values of 0. If there are 3 equations having variables x, y, z, and if the answer is a trivial solution, that means x will be 0, y will be 0, z will be 0. Simple. And if it is non-trivial, it is not equals to 0, which is the case of the second one. That means when the rank of the matrix, of the coefficient matrix A, will not be equal to n, but will be less than that of n. So as you can see here, here are two cases. Case number 1, if the rank of the matrix A is equal to the number of unknowns, that is r equals n. Here r stands for the rank. Anyways, we can represent it by rho also. Then the equation Ax equals 0, which is a case of homogeneous equation, will have non-linearly independent solution. In this case, x will be 0, x1, x2 till xn will be 0. This is a case of trivial solution. Now the second one says if the rank of matrix A is less than that of the number of unknowns, then this is r less than n. This is the case of non-trivial solution. Here it will not be 0. Another way in which we can figure out how the solution is, if the solution is trivial or non-trivial, is to find out the determinant. If determinant comes as 0, it's a case of non-trivial solution. Please listen to me carefully. If the determinant is 0, it's a case of non-trivial solution. This is somewhere students get confused. Why? Because they take determinant to be 0, so all the values will also come as 0. No, this is wrong. Just the reverse case. If the determinant is 0, it is a case of non-trivial. X, y, z cannot be 0. And if the determinant is not 0, it is a non-zero number, then xyz will be 0. So this is the reverse effect here. So if you're doing it by determinant, you need to find the determinant. If it is 0, then non-trivial. If it is not 0, then trivial. So this is all about the theory behind the solution. Let us do a problem in order to understand it more clearly. So we have this particular equation series. We have 2x plus y plus 3z, x plus 2y and y plus z all equals to 0. And we need to solve this particular system of equations. So first of all, we need to check the rank of the coefficient matrix and tally it with the number of unknowns. As you can see here, we have x, y and z, so n will be equals 3. Okay, in the other two cases we don't have z, but anyways, if there is 3 variables in the first equation also, we need to assure it that n will be equals to 3, the maximum number of unknowns present. So the matrix form will be given like this. It's pretty easy to find out the coefficient matrix. Just take the coefficients out and just form the matrix, and variable matrix of course, and yes, there is no constant matrix, so it will be 0 0 0. Now to find out the rank, how we have managed to do that. So first thing that we did, we have put the matrix, and now we have reversed the row number 1 with row number 2. So the way in which we are doing this particular things, the directions and all, these are also there in the video where I have demonstrated the rank of the matrix and echelon form. So if you are not understanding how we have written this particular things, how we are doing this particular thing, I will request you to watch that video again. And yes, so first of all, we have replaced row 1 with that of 2. So previously row 1 was this one, now it becomes row 2, as you can see here, and previously this was row 2, so now it becomes row 1. So this is the first replacement that we have done. All of these things are done only keeping in mind the one single thing, that is we have to reduce it to the echelon form, and once it is reduced to the echelon form, we can find the rank from here. So the next one will be R2 will be changed to R2 minus 2R1. So R2 minus twice of this, so 2 minus twice of 1, which is 0, 1 minus twice of 2, which is minus 3, and 3 minus twice of this, which is again minus 3, and the rest of the things are exactly the same. Third one we did, we have replaced R2 with minus 1/3 of R2. So we have multiplied minus 1/3 with all the members of R2. So minus 1/3 into 0 will give 0, minus 1/3 into minus 3 will give 1, and minus 1/3 into minus 3, okay, let me see once. Yes, so we have plus 3, and when we are multiplying it with minus 1/3, it will be minus 1. Okay, the rest of the things remain the same. Now let us go to the next one. Now we are replacing R3 with R3 minus R2. Now previously let us go to R3. So R3 minus R2. So this minus this will be 0. 1 minus 1 will again be 0, and 1 minus minus 1, that means it will be 2. So 0 0 2, that should be the R3, and the rest will be exactly the same as you can see here. And finally half of R3. So we have multiplied half with the R3 and we have changed it. So half of 0 is 0, half of 0 is 0, and half of 2 is 1. So with this we have reduced it into the echelon form, and we have finally found the rank of the particular matrix, which is 3. So why 3? Because there are 3 number of non-zero rows. Again, what is non-zero row? If any single member to all the members of a particular row is non-zero, then we call it non-zero row. It will be a 0 row only if all the members of the row are 0. So here, as you can see, this one is non-zero because this 2 are non-zero, this one is non-zero because this 2 are non-zero, and this one is non-zero also because this is non-zero. So 3 non-zero rows and rank is 3. So 3, and also the number of unknowns we have already discussed in the first question itself. The number of unknowns are x, y and z, so which is equals 3. So the rank and the number of unknowns are both equal. So the system has trivial solution as per the theory of the solution. So trivial solution means x will be 0, y equals to 0 and z equals to 0, no questions asked. So this is the conclusion of the particular equation series. So I hope you have understood how we have performed this particular thing. It's pretty easy, very easy. Just you need to find the rank. If it is equals to n, a trivial solution. If it is not equals to n, non-trivial solution. Or you can find the determinant. If it is equals to 0, non-trivial solution. If it is not equals to 0, trivial solution. So this is how we are finding the answer. So anyways, with this we have come to the end of today's video. I hope you have understood how we got figuring out the homogeneous linear equations. In the next video we will come up with a new thing, with a new concept. Until then, keep watching and bye.